Good morning, sir. Yes, sir.
Yes.
Okay, so last class already we explained about that what do you mean by data compression, what are the different types of data compression techniques is there, reversible data compression technique, irreversible data compression technique. Next we have seen that in reversible data compression technique using different notation. Second one was run length encoding technique, Morse code and Hoffman encoding technique. So today let us start. So is that clear? So if it is clear, so I am going to move to that next topic. So that one is that reclaiming space in files. So reclaiming space in files. So we told that this is important for exam. So most of the time this question is coming. Explain that reclaiming space in files. So what do you mean by that reclaiming space in files? So uh, if we are going to delete any record, that particular space has to be reclaimed. So that one is that meaning of that reclaiming space in files. So there are two different there are different kinds of operation. It's possible like record addition, record updation, and record deletion. Record addition, record updating, and record deletion. So there are these are the different. Already we know that with the file we can do different kinds of operation like that. We can add record, we can delete record, or we can update those record. So if you are going to delete a record, so the space, whatever that space will be there on that file, that space has to be reclaimed. Or if you are going to update a record, so that space has to be reclaimed. So that one is that reclaiming space in files. So reclaiming space in files, it's basically for record deletion and storage compaction. Record deletion and storage compaction. So record deletion and storage compaction in program number 2, we have seen that how we are going to delete a record. So right now, for example, if you have that one file, so in which we have that n number of record. For example, this one is one record, this one is that one record, this one is one record. So like this, there may be n number of records, it can be there in a file. So if you have to delete a record, so at that time what we are doing, that we are going to mark that record with some special symbol. So we have seen that in program or lab program, that how we are going to mark, that how we are going to mark. So for example, at the beginning of that record, we are going to mark with some special symbol like star. So right now, if I will search that particular record, we have seen that we will not get that particular record. So that means that record has been deleted. So let me write down some example. For example, we have that few records. So first one is the 2VA, next one is that, for example, 1VA, next is 5VA, so this is the USN number, 7VA, next 8VA. So any one of this record, if you have to delete, so what we have to do, that we have to mark that particular record with some special symbol at the beginning. So at the beginning means this one, that character one, we are going to mark with special symbol like star or any other special symbol we can use to mark that particular record, to understand that record has been deleted. So right now you see that if someone wants to search that record by 1VA, so in search So in this search box, if someone will write down 1VA, so at that time it will say that that record not found. So this one is that technique that how we are going to delete a record. So once we have deleted this record, so this space it's going to be waste. So this particular space is not using by any valid record. So what we have to do, we have to reclaim this space. So we have to reclaim this space. So to reclaim this space, what we have to do that there are different kinds of techniques is there for reclaiming space. So this one is also known as that storage compaction. So storage compaction means we are going to next record how we are going to write. So next record will looks like, for example, this is first record, this is second, this one is third, this one is fourth, next five. So in the next file, what will be there? 1, 3, 4, 5. So this way we can write. So this is that one technique what we can do that. For example, this one is that 1.txt. Another file I have created 2.txt. So two way we can delete. Once we are going to copy only the record which one we want to keep. So all those things we can copy in another file. This is that one way how we can delete that record. But it will take much more time. So as we know that to improve that access time, we need some kind of data structure by which we can improve the accessing time. So basically to delete a record, what we are doing that in that same file itself, we are going to mark that particular record with some special symbol. And after that, storage compaction means only right now after deletion, we need to show only those particular file, whatever, or those particular record, whatever that records will be there in this file, and we should escape this or we should delete this particular space. So this one is known as the storage compaction. So there are different techniques is there for the storage compaction. So reclaiming space in files, it can be happen for two different types of record. One is that fixed length record, another one is that variable length record. So these are the two different types of files or two different types of records. We have that one is that fixed length record, another one is that variable length record. So in case of that fixed length record, it will be easy to find out that easy to reclaim that particular space, as we know that relative record number concept. So relative record number, already we have seen that directly we can access a particular record if that file is of fixed length record. But in case of that variable length record, it's not going to be useful. So let us see that in fixed length record how we are going to reclaim the space. Deleting fixed length record for reclaiming space in file space dynamically. So deleting fixed length records for reclaiming space dynamically. So there are two different way it can be there. One is that, so first what you have to do first that deleted records are the deleted records are in marked in some special way. So we have seen that some special symbol is going to be used to delete that particular record. Next is then what we can do that we can find the space we can find the space that deleted record once occupied. Once occupied so that we can reuse, so that we can reuse that space when we add new records. So what does it mean that in fixed length record we are going to mark that particular record with by using some special symbol. Once that record will be marked by that special symbol, we can reclaim that space when we want to add any new record. So right now for this, for that, what we need that a way to find out. So if you have to reclaim that space, so we need that two things to know. One is that a way to know immediately if there are empty slots in the file. So for that, to reclaim that particular space, what we need to know, for example, right now this one is that file. So in this file, there are few record is there. Out of those record, for example, two record has been deleted. So right now, we need that a way to know immediately if there are empty slots in the file. Is there any kind of empty slots is there or not in this file? So yes, in this one there are two empty slots is there, but we need to know that how we are going to know that there are some empty slots is there. So once we'll come to know that there are some kind of empty slot is there, next what you have to do that we have to know that a way to jump directly to one of those slots if they exist. So right now first step is that we need to know that is there any kind of empty slots is there or not in that file. If there is some kind of empty slots is there in that file, then we should jump to that particular location and we should add the new record on that location. So these are the 2 points. So first is that we are going to delete that record with some special character. After that, if you have to add or if you are going to delete that record, so that particular space has to be occupied so that we can reuse that particular space. So to reuse that space, we need to know that is there any kind of empty slots is there in the file or not. If there is some kind of empty slots is there in file, we should jump to that location and we should add the new record. So this is that how we are going to reclaim the space in fixed length record. So now let us see with one example. So for these two things, we have the two different way. One is so we have the two different way. One is that linked list representation. One is that linked list representation and another one is that stack representation. So by using this linked list concept, what we are going to do that we are going to keep track of the empty slot in the file. Keep track of the empty slots in the file. So a linked list, it's going to looks like, for example, already you studied in data structure. So there will be that header pointer will be there. Next, we have that some other pointer to that next. So this one is that linked list representation, and at last it will be -1. So this one is that linked list representation. So to know that how many numbers of empty slots is there, what we can do that we can use this linked list representation. So how we are going to use that linked list representation? For example, let me write one simple example. So for example, right now, this one is the size of each record. So let me write that first record, it's starting from 0, 0 or 00. So in this one, first record, let me write 1 VA 15 IS 01. So next, this one is for that fixed length record. After that, delimiter and rest of the other fields. So I'm not going to write rest of the other fields. So next, for example, 1 VA 15 IS 05. So this is each record size. Let me 50. So next is that 50. Next one is that 1 VA 15 IS 02. So this one is, let me write 100, 1 VA 15 IS 03. So 150, 1 VA 15 IS 05. Sorry, 05 already written, 06. So 200. So like this, some of the records is there in a file. So right now, for example, I have deleted this record. So write down this record has been deleted. So this one is that one record deleted, and this one is that another record has been deleted. So once this two record has been deleted, what we told that we'll use this linked list representation. We'll use this linked list representation to know that whatever the empty slots is there on that particular file. So right now, can you tell me what will be that relative record number for this, for first one? First one, relative record number, what we can give? We can give that relative record number as 1. In this one, we can give that relative record number as 2. In this one, we can give that relative record number as 2. Next, we can give that relative record number as RRN as 3. Next, we can give this one for that relative record number as 4. So like this, it will continue 5, 6. So like this, we can define the relative record number for each of the file, isn't it? So this one is that how we are going to provide this relative record number. As we know that relative record number equal to what? What was that byte offset equal to? How to find out that relative record number? We have seen that byte offset equal to relative record number into size of each record. That size of each record, if first one is that relative record number 1, so this is 50. Second one will be 2 into 50. So if you'll start from 0, so 0 into 50, 0, or if you'll start from 1, so like this we can define that relative record number. So for first one, relative record number is 1, second one is that relative record number is 2, next one is that relative record number is 3. So what we can do, that which particular record has been deleted, so that one we can represent it like this. For example, this one is that linked list. So in this linked list, first will be that header pointer. Now next is relative record number, which one? So we can define that relative record number as RRN as 2. Now it will pointing to next relative record number. So last relative record number is 4. So next relative record number is 4. So like this we can represent it. So for example 4. Now next one will be -1. So this is that how we are going to keep track of the empty slots from the file, that what are the empty slots is available by using this linked list concept. So in this one, what we are doing, that first we are going to delete that record. As it's fixed length record, we can say that what will be the relative record number for each of these records. So first one will be that 1, second one will be 2, 3, 4, 5. So like this we can define the relative record number. So right now you can see that first record, so there are two empty slots is there. One is the relative record number 2, another one is the relative record number 4. So this is that how. Now next, for example, again another record has been deleted. Let me write down one VA 15IS10. So if this record has been deleted, so 5, next one is that 6. So next time what we'll do, then we'll add next one. So next we are going to add this 6. So next we are going to add this 6 and it's going to add. So next 6 will be there and -1. So how many times a record is going to be deleted, that particular list is going to add into this linked list. And to add a new record, first what we'll do, that first we'll go to this particular linked list and we'll see that is there any kind of empty slots is there or not. Yes, so right now that there are 3 empty slots is there. So if I have to insert another new record, so what I can do, that for example another new record with USN number 1VN 15IS012 has to add. So what you can see, that what we can do, that I can take these particular slots from this particular. First I will go to this linked list and we'll see that is there any empty slots is available or not. So yes, is there some empty slots is available. So first one is the relative record number 2. So I will jump to this particular location. So we'll jump to this location and we'll add this one VA 15 IS 12. And after this linked list we are going to change. So now this one will be that header pointer. So after that, first one will be which one? First one will be that 4. Next one will be 6. Next one will be 6 and -1. So this is so to add a particular record. After new record, so after new record, once you are going to add new record, so after that it will jump to this particular location, it will add the new record and it will delete this particular list from the linked list. So this is that by using linked list representation, that how you can reclaim the space. So here itself we told that two things, a way to know immediately if there are empty slots in the file. So how we are going to, so first technique is that by using that linked list we are going to find out the empty slots. And next, a way to jump directly to one of those slots if they exist. So same thing we are doing that in this one. We are directly jumping to that empty slots and we are adding new record. And after that the linked list it's going to looks like. So right now there are only right now there will be only two slots will be available. So now next another record if I have to add. So at that time what we'll do that we'll check into this linked list. Yes, empty slot is there. So 4 is the empty slot. So directly what we'll do that we'll jump to that location. So if 4 is there, so we'll jump to this fourth location and we'll add the new record. After that again we'll see that another record if we have to add, we'll check into this linked list. Yes, there is some empty slot is there. So in this one we are going to add it. So at last if there is no empty slots is there, so what we'll do that we'll add the new record at the end of the file, because there is no new no empty slots is there, so we'll add it into file at the end. So at the end of the file we are going to add that particular record. So first technique is by using linked list. Is that clear? Is that clear or not, that by using that linked list that how we are going to reclaim the space?
Yes, sir.
Okay, so this one is that by using linked list. Now next one is that stack. So in stack representation, we know that in stack it will work in one end, that first in, first out. So in stack representation, what we can do, so we can take that same example. So we can take, for example, let me write another example. So this was that stack implementation. So if this one is that record, so for example, first I will write down 1VA. So just for simplicity purpose, I will write down 1VA01. Next one is that 1VA05, 1VA06, 1VA12, 1VA30. So like this I can write it. So now next is that 1VA21. So if a particular record is going to delete, what we can do that we can mark that record with some special symbol. Let us consider this record has been deleted, this record has been deleted, and next another this record has been deleted. So in stack representation, what we can do that we can define one avail list. So we can define one. So this one is that stack representation. So in this particular stack representation, this particular stack, let us name it as avail list. That means what are the lists are available to reuse. So now for example, let me see in this one. So first record, if it is, let me write it 50. Next one is for example 100, 150. Next 200, 250, next 300. So from this one what we'll do that we can get how many list. One will be 150, one is 200, 150, 250, and another one is 300. So now this one is that avail list for fixed length record. So I will list for fixed length record. So these are that some one file in which there are some records is there, and the deleted records are marked with this start symbol, and whatever the empty slots is there, we are keeping it into a stack. So now 150, 250, 300. So these are the empty slots. So right now, if I now placement strategy is how we are going to reuse that particular space. So to reuse that space, what we'll do that before adding, we'll come to this stack and we'll see that is there any kind of available list is there or not. Yes, there is available list is there 150. So first record, what we are going to do that we are going to add new record in this place. So 1 VA For example, USN number 15, one VA it's going to add, and after that this avail list we are going to delete 150 from this avail list. Now next, if another record, if we have to add, then what we can do, then we'll go to this avail list and we'll see that is there any kind of list is available or not, or empty slots is available or not. So if it is there 250, so in 250 location we'll go and we'll add that 1VA 50, and after that we are going to delete that particular entry from the stack. So this one is that stack representation. So by using this stack representation, what we can do, that we can add new record, that wherever we have to add, we'll come to know that is there any kind of empty slots is there or not. If there is an empty slots is available, we'll add that particular record on that empty slot. So first we'll go to stack and we'll see that list is there or not. If that list is there, we'll jump to that location and we'll store that new record. So this is that stack representation. By using this stack, how we are going to reclaim the space. So in fixed length record, there are two ways there to reclaim the space. One is that by using linked list representation, another one is by using stack. Is that clear?
Yes, sir.
Okay, so if you have understood by your own words only during exam with some example, you can explain that reclaiming space for fixed length record. Now coming to this variable length record. So now one thing you tell me, that in variable length record, which one we can use? We can use this linked list or stack representation.
Linked list.
Yes, is it possible to use this stack? Will it be possible to use this stack representation? It will not be because somewhere, for example, let us consider I have that empty slot. So 50 means 50 bytes. Somewhere I have that 100. Somewhere I have that 20, and somewhere 300. Right now, if one record will come with that 20, so it's not possible. So what I have to do, I have to pop this element, next I have to pop this element, then only I will get that 20. Or if a particular record will come with the 300 bytes, so only at the beginning I have that 50 bytes, so it's not possible to add it. So we can use this linked list representation in case of the variable length record. So the techniques will be same. So if both the concept, that linked list concept, as well as stack representation, if you have understood that very easily, you can write down this variable length. So deleting, now let us write down for this deleting variable length record. So now this one is that deleting variable length record. So in variable length record, what we'll do, let me write down one simple example. So this one is that one record, and next this one is another record. I'm not writing USN number or anything. This one is another record. Now this one is that another record. So the length of each of those records are not equal, so it's variable. So we know that in variable length record we can't use this concept of relative record number. So now one record has been deleted, for example. This record has been deleted. Next one is that this record has been deleted, and this record has been deleted. So these are the three record has been deleted from this file. So what we told that in our representation that we are using linked list representation, or we'll keep that avail list. So what are the list is available. So what are the list is available? For example, right now, if the size of this one is, let me consider 47. The location it's 47. The total how much size is available? So that one I'm writing it as 47. Next one is that another one. Let me write down this one is for example 56. That size available, that one is that 56. Next one is for example I am writing this one is for example let me write it 30 for example. So 47, 56 and 30. So these are that size. So what will be that first we'll write down this linked list representation. So first size will be 47. So in this one next available space will be next available space will be 56. Next available space will be, for example, in this one we wrote it as 30. So that size will be 30. And at last minus 1. So this one is that avail list. So linked list representation for available list. What are the empty slots are available on this file? So there are three empty slots is available on this file. Now if a record, if it will come with that 50, now I have to add a new record. Add a new record and the size of this record is for example 55 bytes. So what we'll do, we'll go to this linked list and we'll see that first empty slots. Is it possible to fix this 55 bytes? It's not possible because 47. Next we'll come to this 56. Yes, it's possible. So what we'll do that, we'll use this particular slots. So we'll use this particular slots and we'll delete this slot. So after deletion, it's going to looks like next will be 47. So this one will be 47, and after that we'll add this. After that we'll add this 30, and we'll make it as a minus 1. So this is that after adding the record with after adding record, that size of that record is that 55 bytes. So what will happen? So once we are going to add that record, so at that time it will take whole the things. Last one byte it's going to waste for internal fragmentation. So this 50. So new record it's going to add. So new record it's going to add, and the size of this new record will be right now 55. And last one byte it's going to waste for fragmentation. So this is that in variable length record how we are going to add a new record. So we are using this concept of that linked list, and we are finding through this linked list the required size is available or not. If it is not available, for example, right now one record has come with that 70 bytes. So at that time what will happen? I can't fix it into this location in this 47 as well as 56 as well as in this 30th location. So at the end only I have to add that particular record. So this is that how we are going to reclaim that space in case of variable length record. Is that clear? Is that clear or not?
Yes, sir.
Excuse me, sir. Sir, if we
Yes.
have by chance 50 bytes we want to add, so it will fit in the size of 56, but what about the 6 bytes? Like if it is only 1 byte, it will go for fragmentation, but what about 6 bytes that will be left?
So this is coming. So we'll see this one. Let's see. Now you studied this in operating system, those concept of that first fit, best fit, worst fit. There are three different strategies there for fragmentation. So one was that first fit, one is that best fit, next one is that worst fit. So these are the placement strategy. So right now, for example, I have that one linked list representation in which, let me write, first is, for example, I'm writing 50. Next is I have that available size is, for example, 100. Next is I have, for example, 70 bytes. The next is I have available, for example, 30. So like this is there. Okay. So right now I got one record with size 29. Okay. So now to reduce this fragmentation, to reduce that, as we know this fragmentation, it's going to waste most of the space, whether it is internal or external fragmentation. So now to add, so the new record which is coming, the size of that record is 29. So I can fit it in this location also, I can fit it in this location also, I can fit it in this location also. But according to that best fit, what we'll do that we'll use this particular block to add that record, so in which only one byte it's going to be waste. If I will add it into this 100, that where that size is 100, at that time what will happen, it will be worst fit. 71 byte it's going to waste for fragmentation. And first fit, that means at the beginning only. So wherever I will, if it can be fixed there only, it's I am going to fix it. So we can't avoid this fragmentation, only we can use this kind of algorithms or strategy to avoid this fragmentation. If it is nothing is possible, at the end only we should add that record. If no size is available, so at the end only we should keep it. Now, once you are going to add that record, for example, someone told, for example, right now, I have added this record, for example, this is 100 bytes. Okay, so in this one, I am adding only 30 bytes. 70 bytes, it's going to be waste. So 71 byte, it's going to be waste. So right now, in this case, again, keep track of this space. It will be much more tedious, so that in the sense that I have to again move to this location, I have to change this particular size, so it will take much more time. That performance, it may degrade. In later case we'll see that how all those things it can be improved. Is that clear?
Yes, sir.
Hello. Yeah, so
Yes, sir.
to reduce that, at best we what we can do, at best what we can do that to reduce this fragmentation, we can use either first, we can use this best fit, so that the fragmentation will be less, or that space wastage will be less. So these are the some of the placement strategies. So same thing also you can explain here. So in these questions, in deleting or reclaiming space for variable length record, you can write down that same concept. So there are three different placement strategies there. One is that first fit, best fit, and worst fit, and can give one your own example, and you can explain to reduce that fragmentation or external internal fragmentation. We can use this best fit placement strategy. So this question, I think every time it's coming during exam. So can you write down? Can you write the answer for this question?
Yes, sir.
So in brief, you know that what do you mean by reclaiming space in files. If a particular record is going to delete, you have to reuse that space. Now, to reuse that particular space, what you have to do? We need to know, is there any empty slots are available or not. We can know those empty slots are available or not by using two data structure. One is that linked list or by using stack. Now there are two different kinds of record is there. One is fixed length record, one is variable length record. In fixed length record, it's very much possible in fixed length record is very much possible that to know that to provide this strategy that linked list also we can use a stack representation also we can use as the record size will be equal for each of those record, and in case of that